Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syazwan bin Aslan. So today I will present about the lab 1 exercise 1, which is our lab is DC measurement of resistance. So today I will present about the lab activity 1. Okay, and this we can see a circuit diagram for DC meter connection, and then we required to do a circuit on the Proteus or Simulink or other simulation software. Okay, and then the first one is we set to the, as we can see on the lab sheet, the resistor is set to the value of 100, 150, 200 until 1k. And this one is 100 ohm, and then we run the circuit. Okay, for now we can see the value of the ammeter and the voltmeter. We must change the ammeter to the milliampere value. Okay, and then we took the value of the milliampere and the voltmeter, and we write in the measure value of current and voltage. And then we start the solution, and then we continue with the other value of resistor, which is 150. We run the program. Okay, and then we can took the value of measure ammeter and voltmeter, and then we continue this step until the 1k resistor. Okay, that's all for the lab activity 1.
My name is Muhammad Azhar Amshah. My matrix number is CE220086. So for today, I will explain about the activity 2. So here we have a circuit diagram that given. And this one, the circuit diagram that I do on the Proteus software, which is we have a power supply, 10 volt, DC voltmeter, DC emitter, and resistor. For the resistor, we have to change. We follow the instruction given in table 1.2. So here first, we have to set 200 ohm first. Then we turn on. The voltage we got is 10 volt, and the emitter is 0.1. So after we convert to milli unit SI, so we get 100 milliampere. Next, we change the resistor to 150. We turn on, and we get 0.06. So after convert to milli, 16 milliampere. For the voltage is still same because this is the series circuit, so the voltage will be same. Next, 200 ohm, turn on, and the emitter is 0.05. Convert, get 50 milliampere. Next, 300 ohms, start 0.03. Then convert 30 milliampere. And last one is 1 kilo ohm. Turn on. Then emitter is 0.01. Then convert, we get the 0 milliampere. So for this one, for me calculate value RT, R1, and relative error, I using the formula that given in the note. So this one is for RT calculate. This one is R1. Then I got this one, and the last one is a relative error. So for the calculated value, probably I get the answer from the given.
Continue to the lab activity 3. And as we can see, this is a circuit diagram for DC meter connection, which the supply voltage of 10 volt and the RA value is 15.5 ohm, and we have also a voltmeter, and this one a resistor with the value of 100. The resistor RA value is changed equally to the from the 100, 150 and 300. Okay, and this is a already complete circuit that are done in the Proteus simulation. Okay, and the resistor value is set to 100, and also the other value is set to 15.5, and the voltage 10 volt. Okay, now we can run the simulation, and we took the value of ammeter and voltmeter and jot down in this 1.3 table. Okay, and then we can continue for the other value of resistor, which is 150 and 300. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azhar Hamshah and my matrix number is CE220086. So here I will explain about the activity for experiment. So as we can see, this is a circuit diagram that we given for this experiment, and this one is the circuit diagram that I do on for the software. So the first one, we have our supplies, which is we have to set to 10 volt. This one is a DC emitter, DC voltmeter, and resistor. For this resistor, we have to change the value, follow the by table 1.4. So first one, we have to set to 150 ohms, and then on for the DC emitter, we got the 0.07. After convert to milli, we get the 60 milliampere. So for the DC voltmeter, as we know, for the series circuit, the voltage is still the same, but the change is current. So let's change to 300 ohm. Start, and the emitter is 0.03. After convert, we get the 30 milliampere, and the last one is 1 kilo ohms. Turn on, and we get the 0.01. After convert, we get the 0 milliampere. So therefore, for the 4 to 5 power, we have to calculate by manually. So the formula are already given in the notes. The answer, I follow the formula that given. So thank you.
Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, my name is Nick Muhammad Amiruddin bin Azran, and also my metric number is DE220179. Okay, for today I will do the exercise 1B for activity 1A. Okay, first we must change the R. They are got 4 types, which is 210, 390, 470, and 860. Okay, firstly 210, and then the result is this, and then we must change the second load, which is 390. Okay, and then we start the run the simulation. Okay, and then we get this result, and then we change the for the third load is 470. And then we run the simulation, and then we got this result, and then lastly is which 860 ohm. And then we will get this result. Okay, with all the result I make is, and the calculation value I made and the measurement value I made is the same.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Riz Hakim bin Muhammad Fardusi. My number metric is DE220118. Okay, today I'm going to present activity 2 in my lab 1. Okay, so I will do the simulation for the series resistance circuit. So this is the series resistance circuit. So as we know, all the current in this circuit are the same. Okay, only the different is voltage. But opposite for the parallel circuit, which is the ammeter is different, but the voltage is the same. Okay, so this is the circuit for the activity 2. Alright, so I have done the simulation. So the lab asks us to find the value of the I that is current and voltage. So we have only to alter the value, resistor value, which is R1 and R2. So the first one is 210 ohm and plus 390 ohm. So this is the R1 and this is the R2. So this is the ammeter, this is the voltmeter, this two is the voltmeter. So here is the current value is 83.332 milliampere. The voltage at R1 is 17.5 volt. The voltage at the R2 is 32.5 volt. So now we have to alter the value, resistance value, which is 390. So we just have to change at this resistor. Alright. Before we want to change the resistor value, we have to stop the circuit first. Then we have to run it again. So now this is the new value. Okay, so now we have 58.139 milliampere. The voltage at R1 is 22.674 volt, and the voltage at R2 is 27.325 volt. So the third one is 470 and 860. Okay, 470 and 860. Okay, now we have to run it again and we can pause it, stop it. Now the new value for the current is 37.593 milliampere. For the voltage at R1 is 17.669 volt. For the voltage at R2 is 32.33 volt. Okay, so for the last one is 210, and we only have to change the R1 because the R2 value is the same. Okay, so now we have to run it again and we can stop it. Alright, for the last one is 46.728 milliampere. That is the current value. For the voltage value at the R1 is 9.813 volt. At R2 voltage is 40.186 volt. Okay, that is how to find the voltage and current value in using simulation. So I'm using the multi-sim software. This is the measurement value and calculation value. It is almost the same. For the calculation value, how to find I, we just have to divide V total divided by R total, because this is I, and I for the series circuit is the same, so we just have to divide V total and R total. Okay, for the V1 we just have to I total just multiply by the R1 value, that is 210. Okay, so this is the value. For the V2 same, we change the value of R2, which is, how to find V2 is V2 equal to I total multiply to the R2. So this is the value. V total, we just have to add these two number, the volt 1 and the volt 2. I mean the V1 and V2. So we have get this all the V total. V total for the all activity is the same, because the supply, we have to get V total, we have to get the same value as the supply, voltage supply. Okay, so as we can see, the value for the calculation and the measurement value is almost the same, but in the calculation value I just round it up. Okay, thank you, that's all from me.
Hello and Assalamualaikum. My name is Muhammad Syami Aiman bin Muhammad Sabri and my number metric is DE220127. Today I will explain how I do it my circuit for activity 3. First of all, my circuit is parallel resistant. So I do it in my multisim online. So I just follow for the example circuit in the experiment. So first, I put in AC power supply and 2 resistance in the parallel circuit. So for the first example is R3 is I put 210 ohm and the second resistance is 860 ohm. After I connect the wire, so I will play to get the value. So the total current flow is IRMS is 41.894 milliampere and the current flow to R3 is 33.672 milliampere and the I2 current flow to the R4 is 8.22 milliampere. The VRMS that we'll get at R4 is 7.0711 volt. Same to R3, 7.0711 volt because it is a parallel circuit. So how I get the VRMS? The formula for VRMS is voltage divided by square root 2. So it will get 7.0711 volt. And the measurement value is, I just do it by manual calculation by using formula complex number. So the formula to find the I1 is VT divided by R3, which is 7.0711 volt multiplied with 0 degrees divided by 210 ohm multiplied with 0 degrees. So it will get the I1. So I will take the first answer that get the value 33.672 milliampere, and the answer with calculation, manual calculation, and the measurement is the same. Okay, so I will continue to the next activity. Thank you.
Okay, and then for the conclusion for this exercise is at the end of this lab, we are able to learn from the exercise 1, DC and AC measurement of resistance. It have two type of exercise, which is exercise 1A and 1B. Okay, for exercise 1A, we can learn to verify the concept of Ohm law and Ohm loss, and also we can apply the Ohm loss in the DC circuit analysis. From the concept, we can determine power in DC circuit by using voltmeter and DC ammeter in simulation software, and then we can compare between calculated and measured values from the exercise 1A. And then for the from exercise 1B, we can learn to simulate AC circuit with our loads and also simulate series and parallel circuits from this exercise. We can read and measure value of AC voltmeter and AC ammeter by using simulation software, and also we can compare the simulated value and calculated value. That's all from me. Thank you very much.